that better? Apparently I landed on the cable and it came out. Anyway, welcome everybody to another stream. How's it going? Thank you, Akros, for the support, the subscription there. Appreciate you. Appreciate you being here for more than 10 months, I guess. I'm sure about it. But supporting for 10 months, that is awesome. Reboot renderer, yes. Yeah, so effectively, I did post in the Discord. I'll give you guys a quick TLDR now, and we'll do a good old recap of what renderers we've done and the thinking behind these decisions in the past and where we're going to in the future. But for those who obviously understand a little bit where we are, I'm just going to give you the quick TLDR now. Basically, we're at a point in this material editor where, you know, we can edit materials and gets a little bit of history. We've still got to be able to select the old history and wind it back and stuff. So it's still not finished. We'll get back to finishing it proper in a bit. But we don't have ways of... we need to add multiple material support to the renderer. But also I'm looking at the current state of the renderer, and I know for the model editor, it's just not going to be... Yeah, it just glitches all over the place. And I probably don't want to stick with the BVH renderer anymore because I think the performance was quite bad, like here. I think if I run I should really get the... Oh, I don't really have an editor up. Hang on a minute. Graphics. Let's run the... There's a performance if-def somewhere. Is that a GPU? Better not be in GPU. Sounds a bit dumb if it is. Yes. So this will run the profiler. And if you run the profiler, performance gets quite bad if you get pretty close. So, and yeah, there we go. So it's 16, 14 ms. To my BVH ray tracer, I'm at 10 ms. I don't know. Yeah. It's pretty bad. So I could obviously make this one better, but I don't think I want to stick with the... I might use the BVH ray tracer later, but I'm thinking that we might try something else first. So I'll keep the code around, and then we can possibly improve it in the future. I've got some papers I want to look at to improve it. But it's quite complicated for what it does. So I want to try and go back to an old renderer and make things more stable, faster, and look at these jagged edges. Ain't they horrible? We'll do some good anti-aliasing as well. So the idea was we wanted to add multiple material support because right now we only have one global material. So if I was going to go and do that work and then I wanted to get rid of the renderer anyway, it would be better off if we just spent some time and just did a proper job and did it all in one go. So this is why there's going to be a bit of an engine reboot, probably up until Christmas. So we've got 1 month to do it. Hey, Cap Payne. How you doing, sir? Appreciate you. Wow, so it's been over a year. How amazing. 12-month streak as well. Awesome. Yeah. Good afternoon, good afternoon. Hope you're doing well. So, yeah, so the quick idea was we want to fix some screenshots, resurrect the old tile binned renderer for those who remember that one. I'll go over the full history in a bit. We want to add multiple material support. We want to have anti-aliasing back so things actually don't look jagged. Possibly support multiple viewports for the editors and render to a HDR texture and do some bloom pass so emissive actually goes boom. You know, actually brightens up the screen and doesn't just sort of brighten up the dark patches of the material of the surface, you know, because it just sort of adds it to the so if we just put the emissive color here, see that just, well, if we say have that and then we do like a, yeah, we'll just sort of add it to that, to every part of it basically, rather than also leaking outside of the object and making it look bright. So we need to want to get that working as well, because it really will add to the visuals. Validation turn off, probably. But yeah, we'll probably fix those validation errors too. There was that one, wasn't it? Yeah, let's add it to the list. We could probably go. There we go. So let me just dig up the history. So there's this first one that we started on was tile binning apparently. This is what we'll be going back to, but yeah. Then I went to BVH renderer because I was like, we want to shoot rays from anywhere instead of the screen. Like anywhere inside the world and stuff. So I was like, let's make a BVH renderer as well. And I was thinking of still having both at this point, I think. When I remember. Oh yeah, this was me trying to think about just having a play around with trying to design an acceleration structure. And I was kind of redesigning like an octree, but then also trying to build a BVH doing octree stuff. It was a bit weird. And then I found this paper, and I started implementing it. Yeah. Right. Maybe I should just get an image of a bounding volume hierarchy instead. And then show that and then say what I just basically said again. Right, that should do, ought to be good enough. Bit too far zoomed in though. Bit blindingly white, what is going on? You know what I can do? I can just save the image. That ought to be good enough. Maybe I can just show the debug view of the BVH. That might just be the way. Past Henry being confused. There we go. Yeah, then I decided to make a BVH renderer, and then I decided to... By the way, if people are interested in catching the previous VODs in more detail, they are up on YouTube. You can always just drop those. Then I think I went back to the tile renderer again. Oh no, I did. I don't know what I did. Oh yeah, I did. Then I decided, after doing the BVH and trying that one out. So the reason why I did all these different renderers was because I was doing R&D. I didn't know what was best, so I was like, let's just implement a whole bunch of different things, and just see what is actually better, and also learn, because I've not done this stuff before, so I thought I'd learn about it by literally just doing it. And it was a good test for my shading compiler as well, just to see sort of what errors I'll bump into by writing a bunch of different algorithms basically. Then I tried Froxel binning, where I was like, okay, how does this compare to... See, it's hard to get proper numbers as well. Where's the top-down drawing? There we go, that'll do it. something like this. There we go. Maybe my face should be a bit different. Oh my days. That'll be okay. Cringe. Then what else did we do after that? Tried out a bit of a Froxel binning. And then I tried to sort of bin into basically an octree structure. Or having it in an octree structure and then take that and then bin it to the screen or something. So it's doing some LOD system. Basically. Because I wanted to try and see if you could have tons and tons and tons of spheres. And yeah, so this took quite a lot of time actually. But I can show a final result. Yeah, this is what I got basically, this very dense sphere of spheres. And then it was tile binned again. And then all of these were like, and then, yeah, so this ended up, I forgot how many this ended up being. It ended up being a few million. Wait a minute, I forgot. Yeah, so it was a real big number. I think this was 9 million because it was or there was a 3x3, and each sphere was a million or something like that, or nearly a million. It was something dumb like that, and then like, yeah, binning those to the screen just to see how many spheres you could put on a screen at once and stuff like that. But then when we added PBR to this, it actually didn't look too great. There's probably ways to fix it though, by not rendering actual spheres and probably doing a point cloud instead, maybe. But yeah, I thought if I was to try to make a game with this sort of renderer, it would have taken, it would have, what would have it done? Just trying to remember now. Yeah, then I made a texture viewer, did some PBR, made things look shiny and reflective, and then went back to doing a BVH again. Bum, bum, bum. And that's the current renderer we got. So how can I talk about this one? But yeah, I hope everyone's having a good weekend so far. What you guys been up to? Yeah, so I tried to then do some LOD thing, and oh yeah, that was the problem. The problem with it was the fact that between two different LODs, I had to try and make it so they didn't pop in. And the way I tried to solve it was with alpha blending. That was it. So you alpha blend the previous 2 levels of detail, but then obviously you have to run 2 levels of detail. So it's actually quite a lot of extra shapes being put into the screen tiles. And I couldn't think of a way around it. So yeah. And then I just said this thing improved AA, so I tried to do it. Oh yeah, that solved the pop-in with alpha blending, and then AA was improved. Right, I see. So how can I okay, maybe I can get one of these up, and then I'll get one of these videos as well. And then we'll talk about... Right, so let's just get the big old sphere, and I can talk about the... Oh, where's the good old sphere? Oh, there it is right there. Oh, so that's the image I wanted. I vaguely remember the talk about hierarchical linear BVH. Yes. Oh, look at that glitchy. Ugh. Yeah, that was the previous one. Wait. Hierarchical linear BVH. No. Yeah, that was... Did I implement that, or is that the paper I was going to do next? Yeah, this is like a bunch of spheres. I think it was 1,000,000. I forget. Quite a lot, though. I forgot what the number was. I don't know if I can guess it from this. But it's a 3D volume, right? So if it's 100, if it's 1024 that way in each dimension, then it's 1,000,000. So I forgot. It might have been 256 though. But yeah, we'll see. I think it was an NVIDIA paper. Yeah. Oh yeah. The linear BVH. That's probably the first one. And then I did a texture viewer because that was a good idea. We can see a lot of... We can take screenshot... Well, okay, the screenshot thing just broke. That's the thing we've got to fix again because we did screen resizing recently. But we can like take a screenshot and in the game and zoom in and see everything about what's going on. So it's very helpful for rendering. See, that was that. We want to show that and then talk about how I duplicated it. And it was... We've got some performance metrics behind the screen here, isn't it? This was... I don't know what that is. It's a ray trace of something. So it says about 2 milliseconds, but hard to tell. Right, and then let's up the quality. Yes, the volume rendering here is... Wait, how's that 1 millisecond? Total 3 milliseconds? Quite alright, isn't it? Yes, I think these were 256 cubed because that's nowhere near 1,000 that way. Oh, wait, no, how many is this? This is 64. What is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So yes, this looks like 64 cubed. So we can actually work this out. 64 times 64 times 64. So it's 256,000 per ball, and you got 4x4. So it's times 16. So it's 4 million spheres there. And this is a tile bin renderer where that was 7 milliseconds there. So as we got close, yeah. So when we zoomed out, that was using the lower LOD. Yeah, we're also monkeying around with this LOD thing as well. What's the minimum height? Pixel height for the... Yeah. Cool, we could show this. Right, this is good. Good content. So, let me just... Yeah, then we did PBR. And then we went back to doing another BVH one because I thought... Yeah, I thought I'd try another algorithm for it. And improve it, basically. I do ellipsoids all the way down or something, and then... Yeah, it didn't really yield what we wanted, I guess. But we still might use it. We could talk about that with the current one. Oh, that font changed. Right, where is it? That's a good one. That's a good visual. It's like spaghetti. Trying to see if there's one with like less glitches or something. I did cover this one in a YouTube video though, as well. But right. It's horrible blob. All right, we'll do something like that. Okay, so I've got an idea. Let's put a new tab between everything that was actually a new renderer, and then I can understand what I'm looking at when I go through all these damn tabs. That's the BVH one. That's the Froxel binner. Right. That's how many renderers we've done. We've done 1, 2, 3, 4, 5. Right. So I just got to remember like why I did these different renderers again. So I guess let's go through the whole history. Right, let's start off with a reason why. Yeah, I think I might record this and put it up on YouTube as well, because it's been a while since I've posted there, and it'll be good to not, because I've done a lot of sort of little work, and it'll be good to make sure it doesn't go so out of sync that if people look at an old video, they understand what sort of things I settled on. That would be kind of bad. So let's just do a quick recap of what we've done. Right. Let's just plop a marker down. Hello everyone, welcome to another video. So it's been a good while, just been busy working on the project, and it's just been a bit difficult making YouTube videos and getting them uploaded, but I've got a bit of an update here. We're going to be classic meme thing of rebooting the renderer again for another time, but I just want to show the progress I've made so far on some other things that I've been working on. So right here you're seeing is an entity system. There's an entity moving around between different sort of regions, and another entity will sort of spawn and then it will get blocked. So it's all like done on this sort of tile grid, which is how the game is going to be in the future. Like as you can tell with this current renderer, it is kind of buggy, hence why I want to sort of redo it. There are some kind of flickers, there are some glitches, and it doesn't seem like it will necessarily scale when it comes to actually putting in a level. So if I was to move the camera back, if I was to probably fill this screen with a bunch of entities, I don't think it will scale very well. The performance here is about 8 milliseconds, and as I sort of drive into the screen, we get about 10 ms. It can even go even higher if we get super close. We'll probably never go this close in the actual game, but it just goes to show there are some performance isn't its best shot. So we're currently using a BVH renderer. It can definitely be improved. Like the traversal code, that is for sure, and probably the Probably the construction as well. There's another paper I wanted to implement, the one I referenced in the previous video actually. But yeah, the problem is shooting rays from the camera and doing a BVH traversal per pixel is probably not the best idea. And in the past, we'd done a different renderer using the screen tiles, just binning stuff in screen tiles, and was able to render like quite a lot of spheres basically for far cheaper than this. So something where we've got to right now has been building some editors. So if I bring up the editor, we've got a material editor. So we can sort of select the albedo, for instance. We've got a nice like OK LCH picker, so we can pick a color using OK LCH, and we'll get, when we shift the hue, we get perceptually the same brightness for the color shifting, right? Which is quite nice. So we select like an albedo, we can select like emissive, it doesn't bloom yet. This is something we want to add, and change metalness and roughness. And then there's some sort of history that shows up. I want to basically save the history out, and you can load the material back in, and it preserves all the history here, so you can sort of see who done it and when, and wind back and stuff like this. But yeah, so I'm going to be wrapping up on this material editor after I've done this renderer reboot, and moving on to the editor where I can actually make some models out of ellipsoids, which would be quite cool. And yeah, so I need to be able to add multiple material support, because right now we don't have support for multiple materials. It's just a single material for every single entity. So rather than sort of just fix this one thing in there and get to the model editor, I thought I might as well fix the glitches, make it more stable in terms of performance, and switch the renderer we will use for the game basically. So let's do a bit of a history of the previous renderers and just a recap of why I changed from them and what I was. Okay, let me do that one. Yeah, so okay. So I'll take you through a recap now of all the different renderers we've done in the past during the R&D phase, and talk about why. I don't want to do that yet, was it? Right. Let's talk about like why we're switching renderers and what we're going to do. Yes, is that. Right, so along with we need to add multiple material support, I also wanted to fix the screenshot system, so we can currently take screenshots and open up a texture viewer and view them in game, which helps us debugging graphics problems. So while we're changing the renderer, it's going to be vital that we have this tool. So that broke when I added screen resizing support, so I want to get that sorted out. Fix some errors in the Vulkan system. It does have some validation errors. We want to bring back the old tiled bin renderer, because for spheres I was able to render a whole ton of them real quick, and it was kind of stable for ellipsoids. So this will have a benefit of rendering from the screen. But if we want to sort of render from other views, we'll have to do another tile binning process for each view that we might want to do. So we may have to have another type of renderer for the ellipsoids in the future for GI perhaps, or shadows. But we'll have to think about that in the future. Support for multiple materials, as we mentioned. Bring back anti-aliasing. Right now I've got jagged edges because I've changed the renderer a few times, and a few of them had anti-aliasing, but the current one does not. So I'm thinking about maybe doing a software MSAA. We'll see how that goes. Multi-viewport support, and render to HDR texture so we can add bloom, so the emissive actually looks like it is bright. You know, it blurs the the neighboring pixels of the model. Yeah, so the plan is hopefully up until Christmas to work on this sort of stuff, and then get back to working on the material editor, finish that, and then work on the model editor and the scene editor, basically. Right. Guess we can close that now. So I want to do a recap. Okay. Right, so in this part of the video, I'm just going to take you through a recap of all the different pass renderers that I've done for this project, and hopefully remember the reasons why I switched on to something else and tried that, because it has been, I forgot when this first one was done. Okay, it says a year ago. It's probably more than a year ago, I don't know. But anyway, so something like that. So there was an R&D phase of the project where I didn't know what I wanted. I hadn't really done this sort of stuff before, and I wanted to try and find something that was kind of distinct, that was not necessarily what everyone else was doing, to try and bring some kind of different art style to the game that we're making. So I wanted to try and render basically a bunch of spheres and see, you know, could I render a lot of them, and sort of how could I go about doing that? So the first one was me just trying to bin a bunch of spheres into screen tiles. And this is the approach I actually want to go back to, or some variation of it, right? So imagine if you split the screen into, these are 16 by 16 pixel tiles, and each of these 16 by 16 pixel tiles has their own arrays, and the arrays are arrays of spheres. And so what happens is when you launch a compute shader over every single pixel on the screen, you basically shoot a ray through the near plane, and you go over the list of spheres that could possibly be inside this 16 by 16 tile, and you see if you hit any of those spheres. And it has the added benefit of, if you sort them front to back, it means you can process them in order, and you can actually do proper alpha blending as well. And you could, we also did some hacky anti-aliasing thing, because it was a sphere and it's quite easy to do it. So in the same shader, was doing anti-aliasing as well. But I think, looking back on it now, probably doing too many things in that single shader was a bad idea, like handling transparency and handling anti-aliasing as well, or maybe not anti-aliasing, or just transparency at least, or maybe the hacky AA thing. Yeah. So transparency is probably better off being done where we do one pass for opaques, render all the opaques, the closest one we hit, and we early out. So if you have an array of sorted front to back spheres per tile, it means when your pixel hits the nearest sphere, it could just basically, the thread can stop. And then if all threads in a wave stop, that's great. The compute shader can dispatch some other piece of work. Yeah. I wonder if it's not going to got the anti-aliasing in it. Yeah. So let me put another marker in. So the way the anti-aliasing would work in this type of renderer is when it would have a near miss, we would check if it missed by about a pixel. And like if we also got a hit, but it was a near hit, did it miss by about a pixel, actually half a pixel on each side, right? And if that was so, it would then make that pixel transparent and then carry through. So then it would carry on. I don't know how easy it would be to do that with ellipsoids, but maybe I might do some MSAA approach instead, or I might retry that one with ellipsoids as well. But it added a little bit more computation per ray versus sphere intersection check. Right, so how many is this? Another 4. That's... How many is this? 3, 6, 9, 12. 15. 19, 21, 24, 26. Why is it 26? Did I just pull that number out? Unless they're in... I have no idea why. Anyway, so I think that's like 26 cubed, and then I got up a whole bunch there. Let's see if we can give some numbers. So I need like 4,000. And then what? We got 9. So it's like 36k. And that was about 3 milliseconds, but this was before doing any occlusion culling, wasn't it? Yeah, that's right. Okay, let's talk about that. Right, so if you take a look at this screenshot here, this is the tile binning one still. And if you look at the performance here, it's about 3.8 milliseconds. And this was rendering, I just ran some numbers based on how many spheres that I see. So it's spinning them into those screen tiles and then going over all of them. It was about, wait a minute, I lost that number. It was in my head and then it just went walking. 26 cubed times 9, wasn't it? Yeah, it's 40 odd thousand. Yeah, it's 40. It's about 40,000. Huh? Oh, did I run the numbers wrong in this? Right, 4, 8. Yeah, so it's about 12. So it's 24. Okay, so it's 24. Don't know why I picked that number. 24 cubed times 9. Right, so it's actually about 125,000. It's all right on it. And this is before I did any occlusion culling or anything like that. That was it. Hey there, Wajilla. How you doing, sir? Appreciate you. How you doing? Let's give you a... good to see you, my friend. What have you been up to? Right, let's jot this one down here. Right, so this is actually that tile binning renderer that we just was going over, but this is just trying to push it to its limits to see how many it can do. And so if you look at the times down here, it's about 3.8 milliseconds, and I ran some numbers based on what I see, and this is rendering about 125,000 spheres. And this is before we got any occlusion culling. Right, so there's a whole bunch of spheres behind spheres which block the spheres, which are blocked by the spheres in front. So really, you could actually just decide to not even put them in the screen tiles entirely. So you save with like doing the binning process and copying them into memory. So you save time there, and you also save with actually potentially iterating over them or something like this. No, you wouldn't save iterating over them. Yeah, you save just basically copying them into the screen tiles. So you save with that. But yeah. So okay. Been mainly working on SIMD optimized mouse library. Cool. It's actually not as bad as people say it is. Nice. Well, is it because like using SIMD intrinsics in C kind of sucks? Like there is, you have to include like a big old header, and then so I think the best approach is you try and make your own header for SIMD, so you don't make your compile times bad. And then the only other problem with like SIMD optimized mass library is maybe, I don't know what you got, the if your vectors aligned to to 16 bytes, right, to 4 components. Is that what people complain about? I've not really done one, I've just sort of seen the issues, and yeah. But yeah, definitely a wise thing to do at some point. But I think most people who do SIMD typically do stuff in like an SOA thing rather than having so you do all your X components together and then all your Y components together in the same register, versus doing it as a whole vector for stuff like that. You can load online memory, which is 4 times slower than aligned, but is still faster than traditional. Okay, is that what you do then? Right. What did I want to speak about in regards to this renderer? Damn it! There was something to do with the current one I wanted to do. I've seen the languages that have SIMD types have made me use it more less control than intrinsics, but much more elegant. Yeah, I guess so. I guess that does help. Right, there was something to do with, so it's talking about the number of ellipsoids and the saving performance with the not binning it into the tiles. Yes. Right, I remember my train of thought. Oh, why am I playing past Henry? So, the reason why this renderer makes a ton of sense is because now I've moved to wanting to render ellipsoids, and I don't necessarily want to render like such small amounts of ellipsoids. Possibly, I think with the art direction I want to go is the ellipsoids are probably going to be reasonably sized on the screen. So if this is 126,000 before doing any sort of optimizations, I guess the screen resolution here is, you could say, is about 960 square. So that's something to take into account. But if we could say it's about 4 milliseconds to render that many spheres, and if we do the same for ellipsoids, it will probably be, yeah, that should probably be plenty enough. So, and we can still, I think there's still room for optimization because I've done some more work, which we will, well, done some more work in the future, right? Which we'll probably touch on in a second. Yeah, so that was a good recap there. Right, so moving on to the next renderer. Yeah, I guess you could have the manual explicitly aligned. You can have the unaligned is default. Then if you know it's going to be aligned, you can have it as a an extra function. That could work. Right, so my next renderer to take a look at was a rendering with a BVH, so which stands for bounding volume hierarchy. So essentially you take like, imagine if you take like a group of like 4 spheres and put a box around it that are close to each other, and then you've got other groups of 4 spheres with boxes around them near you, and you put a box around those ones, and you keep putting boxes and you form a tree, basically. So you form a tree of boxes inside boxes, and then eventually you get to spheres. It's quite a very well-known technique. Actually, all the ray tracing APIs, the implementations underneath, from my understanding, they all use a bounding volume hierarchy. So this is why I thought I would investigate it and try and build my own using compute, and just see how it would go. So this sort of like weird sort of spaceship looking thing, and this is and the reason why I wanted to experiment with this is because not all, like the downside with the tile binned approach is that when you launch rays through the screen, that's what the acceleration structure is built for, right? You've gone and sorted it all into those tiles and made those lovely little arrays per tile, and you can only shoot rays from that position in the world and add that field of view, and that's what the acceleration structure is built for. But as soon as you want to do like shadows and maybe do shadow maps or do GI, or do ray trace shadows or whatever you want to do, right? You need some acceleration structure which doesn't just work from the camera's perspective, but also from other perspectives, or maybe from the surface of an actual from the surface of an object. So this is where I thought I'd try the BVH and see how it went. All right, let me recap. Let me try and get some thoughts back on this BVH thing. I'm just froxed off that one at yeah. And so the hope was with the BVH is that maybe, just maybe, right, if the BVH was fast enough, we don't have to have all these, I don't have to have a screen optimized acceleration structure, tiles or something like that. I could just have this BVH renderer, and that would just be great. The code could be simplified, right? Just you do one path and that'd be cool. But I think in reality, just looking at the numbers that I've got from, I think I tried this BVH thing a couple of times, and there are still improvements that I could make, that is for sure. But I don't think you're going to get good overall performance with just using a BVH. And I think if you take a look at some of the talks from other AAA companies when they use the ray tracing API, the hardware ray tracing where your RTX or the AMD one or whatever, they say they can typically afford like half a ray per pixel in their budget for doing ray tracing, which really isn't a lot, and that is using a bounding volume hierarchy. So if we're going to be doing ray tracing or anything like this, we really have to be Yeah, so after hearing those numbers and trying to a bit out for myself, I kind of Interested in other approaches, like which I won't necessarily get into today because we're just visiting the history, but definitely going back to this tile binning one seems like a very good idea after everything that's that I've tried out. But I think I have another sort of problem with these bounding volume hierarchies, and that is, say if you like start a ray from a surface of a sphere, right? You've still got to do, you can't just sort of start, you've got to traverse the whole tree down from the top first, and then eventually you get down to where your sphere is, and then yeah, it's a bit, wait, maybe I didn't articulate one well. Maybe it's better if I can draw it out, but yeah, I'll retake that whole thing. So that's why when I sort of heard those numbers and, you know, done all this research, I was thinking that possibly doing other approaches other than a BVH is a wise idea. So I think if you, yeah, so obviously doing a tile bend approach from the screen side. So we're trying to, it's kind of like, yeah. All right, so one more time. So that's why when I heard those numbers and, you know, done that research for the past year, going back to something like this tile bend approach is definitely a good idea. But then also doing something else for the sort of other perspectives where you sort of shoot rays, like from the surface of a sphere, or from maybe another, or maybe we do shadow maps, right, from another sort of camera perspective. Yeah, so I think there's a couple other techniques I've seen, like with basically if you render the whole world into a 3D volume like a voxel structure. Those have been around for quite some time now. But you know, if you see like a game where people have like a voxel structure inside a texture and they ray trace or ray march through that sort of volume texture, I feel like they get much better performance than actually traversing a tree of nodes. And also the complexity in the code to traverse a tree of nodes in GPU is kind of a bad idea, because you get lots of branches and GPUs do not like divergent paths in branches. And yeah, my traversal system right now I don't think is good at that. Hence why the performance is actually quite bad. And can be improved. But yeah, it is inevitably a problem with BVHs, I find. Right, does anyone in chat have any questions over the stuff so far? Because yeah, maybe that could be useful. But yeah, we're nearly, yeah, I guess we're not, we're halfway there now. Let's take a little drink right now. Let's get that music going again. I did not realize this morning I'll be doing a recap like this, but it's good. It's really good. An advert. I love how Brave is just like, let's block all the ads on the internet, and then they're just like, yeah, advertise on their own homepage. Right. Yeah, any questions I'll answer, but for now, let's do questions. So the next one was the Froxel binner. That was the idea. Right, so another one I wanted to try was maybe if we bend them into Froxels instead, and what was we doing? So I think okay, let me remember this one. So in the past, we had a Froxel, we had a screen binning, and the way I did the screen binning was fixed sized bins. That was it. So maybe I was like, maybe we can make them fixed size bins per Froxel. Okay. And then later on, I discovered we could sort them using AMD's sort. That was it. Do like a radix sort. Yeah, okay. I understand. I remember now. Right, so the next approach I wanted to try was this sort of Froxel binning approach. So the problem I had with the tile binning approach in the past, and ended up fixing this, was basically, how do you allocate an array per tile on the GPU? Seems like a hard problem. So there's a few ways you can solve it. One way, and this is the way we did it in this, is you basically fix allocate a maximum size, right? And it scales quite quickly, but it scales with the resolution and how big your tiles are. But say if I had like 64 per 64 per screen tile, you would then go over every single sphere, take the bounding box of the sphere in screen space, and then go over all the tiles and then add it to the list, right? And then if it overflows the list, you have a problem because you've got many threads all trying to add it and it's not deterministic. So you basically end up overflowing it and then you start getting graphical glitches because on one frame, this sphere gets in that tile, and then the next frame, the other sphere gets in there. And it becomes a big problem. So I remember I said if you sort them like front to back. I think this was before there was that front to back sorting thing, this implementation. So when I tried and did this Froxel one, I was like, maybe we could, if we break it into Froxel. So what Froxel is, imagine this is the near plane down here. This is looking top down on the camera. So the camera looks out down the Z here. And effectively, imagine if you take those screen tiles and you just project them out into the world, and then so they will grow as they get further on, right? So the idea was, why don't we just take the spheres and instead bin them into Froxels, and then this problem will appear less, right? So, I then soon found out that it was actually just a bad idea, and a better approach would be if I were just to have them sorted front to back. What I can do is I can early out when I hit an opaque sphere, meaning that the optimization the Froxel one would have got me, right? Because the Froxel one would have got you this. If you trace your array through the pixel, you're in this bin. So you go, hey, what's all of these spheres in this bin? And you go, there's 8 of them. So you check 8 of them. Maybe that's a bit too many. Maybe there's 2. So you check 2 of them, and then you miss. So then you go to the next Froxel. There's 1 sphere in there. Turns out you hit that 1 sphere, right? But then behind it, there was a lot more scene complexity as you go on. So this one maybe had 40 spheres, and this one maybe had like 30. And there's maybe a lot more complexity in these ones than you've earlied out, right? So essentially by bending them into the Froxels, you could go over a smaller list, which are closer, and you're more likely to actually hit. But there's also problems of going over empty bins and checking those. And so yeah, the idea was, or the improvement was, if we just sort them front to back, you just have that linear list, and it's cache efficient. You just go over the screen tile list of spheres, and it would just be much better that way. So the way I actually achieved that is I used AMD's parallel sort. I ported it to my compiler, so HCC, so I ported it from... So AMD does a really good job of making it open source, right? And so you can get it from their GitHub. and it's just a radix sort. So it's a parallel sort on GPU. So what it means is you can put like the depth in the wait a minute. Yeah, you can have a key for depth, so you sort in by the depth, and in the sort of high bits you can put the tile index. So it means you can maybe I can draw this out. Yeah, it's just too. Why am I drawing out? Right, how am I going to figure this one out? So it's like, imagine if you had tiles of like 16 by... Is that what it is? 16 by 16? Sorry, your tiles are 16 by 16 pixels, but imagine if you had a, say a 1080p screen. It's 120... Yeah. And then times that by 4, that would be 4K? Yeah, okay. So you would need 16 bits. And then the depth would go in there, and then the payload. This would be the sphere index or something like that, whatever it is. And this is known as the sort key. There we go. Right, so with that AMD parallel sort thing, the really nice thing about it is you can pass in 2 arrays, and when you index into the sort array, the same index gets you the payload for that sort key. So essentially, if you were to put in a sphere, you put in the sphere index into the payload at 0, for instance, and then at the 0 index you put in the tile index and the depth into the sort key. So the way you can bin them into screen tiles is simply you just fill an array with every single sphere that gets binned into a tile. So you go over all the tiles that one sphere gets binned into and insert into the array, and for each tile it hits. And so you go right. So the first 16 bits was the tile index. This will support up to a 4K screen with 16 by 16 pixel screen tiles. So if you need a high resolution, you would need to either change the size of your tile or increase the number of bits in the sort key. And then in the low bits of the sort key was the depth. So this means that when the parallel sort has done the sorting, the most significant bits means that they'll get sorted by tile index first and then by depth. So within one sorting pass, you can sort all of your spheres into screen tiles and they'll be sorted front to back inside the screen tiles, which is quite powerful, but it does involve doing a full radix sort over a bunch of spheres. So you want to make sure that if you're going to render or sort a lot of things, you want to try and maybe get rid of some that actually won't be rendered when you do this. But and that's some of the work we did in the future, but that's the basic idea. And this is how that made the Voxel binning approach redundant. Cool. Right. What's this next one? Okay, so with this renderer, I thought, you know what? I want to try and see how many spheres I can actually render, because So I did that tile bending approach first, then I did the BVH one, then I did the Froxel one, and I was like, well, the tile bending one was just really fast. How many spheres could I actually render? So what I thought I wanted to try and do is have some like octree LOD system where sort of each node in the octree had an 8x8, or was a 4x4, I forget. I think it was a 4x4. 4x4 set of, sorry, 4 cubed set of spheres. And, oh, wait a minute. There's a few different approaches. That's why it took so long to do. Yeah. Right, so this next sort of render I actually did a few different times because I wanted to change different sizes of things and re-implement it as well. So this one actually took the longest. This was the longest piece of R&D I'd done in terms of renderers. So because I'd done the tile bend ray tracer, the BVH ray tracer, and that Froxel ray tracer, I wanted, I saw that the tile bending one was much better. So I thought, how many spheres could I actually render if I added some LOD system to it? So the LOD system is basically an octree, right? So every node has possibly 8 children split evenly, right? And each node also has I think one implementation had a 2x2, another implementation had a 4x4, and I think another had an 8x8. I'm not quite sure on that, but it's something like that, and that's the reason why I tried it a few times. So the idea was each node had a 4x4x4 set of spheres, and when it had children nodes, it means that there was a higher level of detail for those spheres. So maybe the sphere maybe had, it had a bunch of spheres inside that sphere basically, and that the parent sphere was a lower level of detail version of it. But yeah, so yeah, this was very glitchy, this one here, but effectively this was still using the tile bending approach. And this is a model instance that's been rotated in world. So there's like the axis line bounding box in view space, and here's the world space box around it, something like that. Or the local space box, I forget. Right, there's another one here for this one. Right, and this is when I tried to sort of go, okay, well, we've got one of these now. So, so I guess the thing to take notice with the LOD system is that you could choose like a minimum pixel height for the cluster. So each one of those nodes, those 4x4x4s, was known as a cluster. So this is the height you wanted the cluster to be in pixels, basically, when it was accepted to be rendered. Whereas if it was sort of smaller than this, it would use a higher level of detail or something. So I had a slider where I could drag it, and as you move the camera, it would use a lower level of detail. So as you can tell with this sort of title here, this was the I tried to fix the pop-in. So when you switch between levels of detail, because it's only using, imagine if you have a 4x4x4 set of spheres, and then you go, right, I'm going to replace those with just one big sphere. Well, obviously it's not going to fill the same space, and you're going to clearly see that change. So I tried to fix it with a sort of a fade. So you basically render the current level of detail on the one before, or whichever way around it is, the next one and the one and the current one. And so, but you sort of blend them in and out. You basically just make them transparent, since I already had the front to back alpha blending thing in. So yeah, this is just me playing about with how far does it go. I think I'm halfway through doing it, to be honest, in this scene. But yeah, just see if there's a better view. Yeah, this is when it's a bit better, I guess. So we'll sort of like fade them in and out like that. There you go. See if I can find a good. Here we go. Right, so this is when I put the sort of min pixel height for a cluster to 6. And as you can tell, you get lots of like visual artifacts here where the spheres are so small that like the normal is like very different as you sort of move. Yeah, like essentially the spheres are kind of getting to the point where they're probably sub-pixel or maybe a few pixels. And yeah, it just doesn't look right. So that at that point, you're probably better off just not rendering them as actual spheres and probably rendering them as like a point cloud or something with like a proper surface normal or something like that. But yeah, I didn't really want to go with that approach because yeah, I guess you can do some cool stuff with point clouds, but I want to do stuff with kind of spheres, and I didn't think this LOD approach was going to end up actually looking good because when I did a PBR pass, so I did physically based rendering, and that's what you see in today's renderer, is a nice sort of like shiny and kind of got some physical correctness behind it. And when I applied it to this renderer, yeah, it made the because the spheres were so small and the normal was so different per pixel that it just made it look horrible. Like it was literally just like sparkling, so many things sparkling. And so this is obviously before that, but so in terms of performance, I cannot give you exact numbers, but because it was like an LOD system, the other main issue with this one is if I wanted to stick with it, is I would have had to have rendered 2 LODs at once and alpha blend, and so that would have filled up the screen tiles with more things, and more spheres would have got sorted right in their massive sort pass, and it's just ultimately wasn't a good direction to go in the long run, visually, and also performance wise there's probably a lot of waste. So this is why I went back to just trying to do some bigger spheres, but then I switched to ellipsoids because I was like, you know what, spheres are probably a little bit limiting. We could want to at least have 3 axes of radius instead of 1. So then I went and did another BVH renderer, but this time with, instead of the bounding box being axis line bounding boxes, they were then ellipsoids instead. So it was ellipsoids all the way down, and the hope was to reduce the branches a bit by just sticking to a single type of thing that gets ray traced. And yeah, this is where we are today with this renderer, and you've seen the problems with it currently and why I want to switch away from it. But yeah, the idea is still sort of similar. We want to render these nice big ellipsoids, build models out of them, PBR, and yeah, but do that with the tile binner instead. All right, so I think that's the history. Has anyone got any questions about that history? Because that was kind of a lot. I don't know if I've missed anything. Or is there anything else I want to talk about? I even talked about the future on white here, and yeah, I think we'll just close that one out, and then we'll just actually get started on doing stuff today, programming wise. I think that'll be very good. Yeah, I haven't done one of these for a long time. What was the what was the last? So for those who don't know, I actually have a YouTube channel where I have posted in the past sort of updates for this project that were kind of in shorter videos. Some of them are quite long, to be honest. It's been 2 months since I posted the last one, so it's not been actually that long. But we'll do another one quick. So just double it, that was 18. Let's just do like 19. Let's just not put the days in anymore, because that's just like... Right. Yeah, let's close this out and then we'll get some work done. Actually get started on it. Right. Okay guys, thank you for watching. I hope you guys enjoyed the video. So that is just, okay. Let's not thank first. I'll come later. Right, so that's the recap of the history of, okay. So I want to go, so there's the history of all my different renderers, and where we're heading to next. It has been a while since I posted the last ever video. It's just quite difficult for me to kind of get these things together at the same time of streaming and working and everything. But you know, hopefully there'll be some more in the coming up soon. But yeah, in the meantime, if you guys want to pop in and say, hey, we do stream live on Tuesday, Thursday, and Sunday, check out Twitch for the time for the times in your time zone. And there's also a VOD channel if you want to skim through the VODs or watch the VODs while you work out, whatever, I don't know. And yeah, just keep up with the stream that way. There's also Discord if you want to come out in the meantime, hang out in the meantime. There's lots of good people in there talking about graphics and programming in general. Just, well, okay, C-base, C++, that sort of thing, you know. And also making games as well. And then, yeah, if you want to support the channel and support the project, if you support via Twitch or Ko-Fi, Ko-Fi is much better for me, guys. And I also appreciate everyone who's already supporting me. But yeah, all the supporters get access to the code and can run it on their machine on Windows and on Linux as well. Yeah, you know, maybe I'll do that one more time. It's been a while since I've done this outro. Right, so that's the recap of all those different renderers I've been right. So there's the recap of all the different sort of renderers I've done during that R&D phase and where we're going to be heading to in the future. Yeah, it's been a while since the previous devlog, but you know, I'm quite busy working full time and also streaming as well, and it's quite difficult to find the time to cut a video down and put out onto YouTube. But whenever, hopefully there's a time soon where I'll get another one out. So yeah, if in the meantime, if you guys want to, you know, tune in live and, you know, we'll just pop in and say, hey, there's a live stream Tuesdays, Thursdays, and Sundays. Check out the Twitch link to actually see the time in your time zone. There's also a VOD channel where I just upload them when they're finished. You can maybe skim through them if you want, or watch them while you work out or something. I don't know. And then there's also a link to the Discord where we you know, talk about programming like C, C++. Also, you know, working on games and 3D graphics too. Lots of cool people in there. And there's also a GitLab where if you guys want to, oh my days. I'll just take the first take. And then I wanted to say, like, right. Alright guys, thank you so much for watching. I'll see you in the next one. Right, finally I can relax now. Alright, so let's talk about what I want to do today. You know, there is like an old renderer file still. Yeah, so it's just so stressful thinking like this thing's being recorded, but then again, it is already being recorded. And my mind is just like in a different mode. Is there a graphics.old folder? Yeah, there is. It's hidden. But yeah, I think in here there's like volume spheres, tile bidding. Yeah, I think we can look at this, but yeah. So I think we might get started on like taking a look at the old code, see what we can take, and see what we're going to have to rebuild and start rebuilding it, and probably just start getting the tile binning thing back in there. So just filling in an array of spheres with tile indices and calling the parallel sort code. I think it's different when you're trying to concisely and professionally get things across rather than just doing your own thing. Yeah, I guess so. Yeah, just like blood pressure. I also don't like just standing up in front of people and talking. It's always like, you know, really like, yeah, lots of fear about that stuff, you know, just standing up and talking in front of people is just scary. Like, I think the most difficult thing for me is just like when you say something and it's silent, you know, it's like, how do you respond to that? For me, is just difficult. And I think I got used to streaming now because I've been doing it for so long. But for the longest time, I couldn't cope with that. And I think I still have that for some reason, even though I can do this. But yeah, it's just a little bit weird. There's levels to it, I guess. But yeah. Yeah, and then faces in front. Yeah. That's true. There's faces. You know, and also when you're speaking in front of a crowd, people usually are just listening to you, so they don't and they're not supposed to respond to you. So I think it's just a weird thing where it's like I want someone to respond to me, but like that's not that environment. So it's just a bit of a weird misfire in my brain, I think. But yeah. Cool. I'm just gonna take a drink. I'm gonna like hydrate because I've just been talking for I don't know how long that was without drinking. So I'm just gonna hydrate for a sec. We'll come back and yeah, look at some old code and basically get started on the tile binning again. Well, yeah. Oh wait, or maybe should we do? Hang on a minute. Maybe we should look into some other stuff. There are some things to fix. It was to do with the. Yeah, maybe we should fix the screenshot button because screenshots are very important. Like we can't do graphics without screenshots. Like it's just very important. And then we'll maybe look at some validation errors too. Right. BRB. Right, welcome back everybody. How's it going? So let's take a look at the screenshot viewer. You know, screenshot viewer is a vital tool in our toolbox, along with the texture viewer. So you press F9, up comes the texture viewer, instantly got two screenshot windows open. These things are in sync, so when you scroll through one of them, it scrolls through the other one as well. But you'll notice that there's a bunch of like noise. And that is because Rohan, thank you so much, sir. Appreciate it. Appreciate your support, sir. How have you been? It's been a while. It's been a while. How you been, sir? So the screenshot view is great because we take a screenshot, zoom in, and be like, look at those jagged edges. They're horrible, right? We can improve the renderer there or see exactly what problems are going on. So it's a key feature. So the problem is, right, is we added screen resize. Apparently I didn't add screen resize. What did I do? Oh, what have I done? Got device lost? Well, I'm glad. I'm glad that it's not bringing my whole GPU down. The compute shader has been rejected. CD message. How do you view D message again? Yeah, how do we Right, have I got to sudo this thing? Right. First initialized parser -2. Great. Clearly problem on my end. Right, so I don't know, I've got to maybe seriously, what's going on? So when you resize. Anyway, we had a screen resizing, and let's finish up what I was saying. So we had a screen resizing, so what happened is these screenshot textures used to be fixed width, and they're no longer fixed width because we can actually resize the screen. So I was like, okay, I'll put it in the maximum resolution that it could ever be. And then now we've got this uninitialized size. So I've got to like think about how I want to solve this properly. And then what happens if you load different sized textures or something like this? So I want to solve that well because it's a very good tool. But let's just fix the screen resizing. We'll see what's going on. So I have a feeling that it could be one of the newer shaders that I've done. Maybe. Although there is... Let's turn off this... Yeah, let's turn off this performance thing. Now, what did I change since I got it working? We do have Git as well, though. Get proc address. Why am I getting a proc address? Oh, I'm not. So it fails to do submit. This is not happening before. Maybe look back in the Git log. So yeah, maybe we should fix this resize first. Right, so you did more on the material editor twice. Really? 3 times. Okay, very unique messages. Fixed incorrect window size, which leads to randoms being different from the mouse position. So that was on Windows. Update HCC because I added support. I changed the storage texture API. Dark on material editor, screen resizing. Yay. So this is where I last worked apparently. So what changed in the renderer since then was these things, but I'm pretty sure it worked. And no, what changes have I got? They're okay to get rid of. Let's get rid of all of those maybe. I can't get rid of all of them. I just changed. Oh, that's a weird one. Yeah, let's just commit that. File format. Oh, you're right. Maybe, do I have the validation layers on? That's a good point. I did not think about that. I just assumed I did. No, the validation layers I think are on. Yeah, because they showed up in the call stack. So let's see if we go back to another commit. So we go to, I think you just say switch day. Let's switch to day 190. I think you do git switch. We can always do, let's do 190. Right. So if I were to run this current version, right, how does the screen resizing go?